So, in part 1 we have just find prop reaction and do shear force calculation. Also found that the point where shear force changes its sign, that is point of contra shear, and its position. Now, let us have calculation on the bending moment for the given beam under the given loading. Bending moment calculations. Now, here in diagram you can see loading diagram, there are only two nodal points, that is both ends. Now, we do not know the exact shape of the bending moment diagram, but we know that concept that in case of point load or concentrated load, the loading diagram or based on the loading diagram or based on the types of loading on the beam, the shear force and bending moment diagrams vary. Okay? And based on the relation between load, shear force and bending moment, we have already seen in strength of material module shear force and bending moment diagram that the for point loads shear force diagram will be straight or horizontal line and bending moment diagram will be inclined line. And in case of UDL, shear force diagram will be have inclined lines between 2 points and bending moment diagram will be shown by a parabolic curve. So, to draw exact parabolic curve, we will find bending moment at different points. So, at span is 3 meter, we will find at 1 meter and 2 meter or at the fixed end from the support B. So, bending moment at 1 meter from B will be equals to upward 4.5 multiply by 1, as we are finding moment at 1 meter, minus this downward loading 4 into 1 into 1 by 2 will get answer as 2.5 kilonewton meter. Now, similarly find bending moment at 2 meter from B. First, how to find? Yes, same 4.5 into 2 minus 4 into 2 into 2 by 2. Here it is not 22, it is 2 equals to 1 kilonewton meter. So, at a distance of 2 meter from B, shear force bending moment is 1 kilonewton meter. So, both are positive. Now, you can see bending moment is reducing. At the prop end it is 0, at 1 meter 2.5, at 2 meter 1. So, it is decreasing. So, at A it may become negative, let us see. So, at support A, that is at a distance 3 meter from B, 4.5 into 3 minus 4 into 3 into 3 by 2, we will get minus 4.5 kilonewton meter. So, here at fixed end its hugging moment or negative 4.5 kilonewton meter. So, part of the parabolic curve of the bending moment diagram will be positive and part or some part will be negative or below the datum line. So, again it can be observed that the bending moment is changing its sign from positive to negative, okay, in between distance 2 meter and 3 meter from the free end or near the support. So, we have to find that point also, as we know that point where bending moment changes its sign, it is termed as, yes, okay, it is termed as point of contra flexor. Now, in case of UDL, we know that bending moment diagram is parabolic curve. So, again at the point of contra shear or where the shear force is 0 or changes its sign, that point will occur maximum bending moment. So, let us find bending moment at a point of contra shear. So, which is at a distance of 1.125 meter from free end, we can see in the diagram. So, we have to find bending moment at this section. We will just take moment at this section towards left or right of this section. So, at right you can see there is only 2 forces. So, we can, our distance is also less, we can easily do calculation for this portion. We will go for right side of this section. So, maximum bending moment at point of contra shear or a distance of 1.125 meter from free end will be equals to 4.5 upward reaction into A means 1.125 minus downward load 4 into 1.125 into 1.125 divided by 2. Okay. So, by solving you will get maximum positive bending moment as 2.53 kilonewton meter, which is in between 1 meter and 2 meter distance from the free end. So, with the help of these points you can easily draw the exact bending moment diagram. So, likewise you can draw the shear force and bending moment diagrams. You can see here the shear force at support B is 4.5, that is upward prop reaction, at A is downward or negative, that is 7.5 kilonewton. So, these are joined by inclined line due to the UDL. Now, here somewhere there is a point that is at a distance of 1.125 meter where shear force changes from positive to negative, and that point is termed as point of contra shear. Okay. Now, again you can see in the bending moment diagram it changes from positive to negative bending moment, or somewhere in between fixed end to free end there is a zero moment. Now, what is the term? Yes, what we will say to this point? Okay, this is termed as point of contra flexure. So, which is at a distance of 2.25 meter from the free end. Now, how this 2.25 meter came? So, let us find the position of this point of contra flexure where shear bending moment is 0 or changes its sign from positive to negative. Let us see. So, position of point of contra flexure can be find same as we have find for the point of contra shear. Let us consider a distance x of the section from the free end where bending moment changes its sign. You can see in the diagram there is a section which is at a distance of x from the free end or prop end where bending moment changes its sign. Now, we know that by the observation in the bending moment diagram we can see that at this point bending moment is 0. So, we will take moment at this section or left or right to this section to find this distance. We will equate with 0. So, write the bending moment equation. 0 will be equals to 4.5 multiplied by x moment of this upward reaction minus 4 times x into x by 2 moment of this downward UDL. So, just equate it, and by solving we will get this x distance as 2.25 meter. Everyone got this answer? Okay, note it down. So, likewise we can find the position of point of contra flexure for a prop cantilever subjected to UDL over the entire span. Hope you can find by your own for the numericals, or we can say that point of contra flexure is at a distance of 2.25 meter from the free end. So, here we will stop. Let us summarize what we have learned in today's session as well as in previous session about the propped cantilever. We have learned that propped cantilever beam is a indeterminate structure. Again, the indeterminacy of this prop cantilever is 1, and first to calculate the prop reaction we have to use consistent deformation equations. In this session we have gone through a numerical subjected to UDL. For this we can remember this equation for partial UDL. There is equation of deflection at free end when load is in between fixed and free end in the form of UDL, that is WL1 raised to 4 divided by 8ER plus WL1 cube divided by 6ER in bracket L minus L1, where L1 is resistance from the or span of UDL from the fixed end. Okay. Again We have drawn shear force and bending moment diagram. With the help of shear force values, we are now able to calculate shear force values at different nodal points with the help of reactions and loading conditions. Also, we have find bending moment at different points and drawn the bending moment diagrams accordingly. So, based on today's session, let us have an assignment. Hope you can solve. Note it down. A horizontal cantilever 6 meter long carries an UDL of 5 kN per meter over entire length of 2 meter from the fixed end. If the beam is propped at free end to the level of the fixed end, find the reaction of the prop and construct shear force and bending moment diagram. So, hope you can solve this numerical in assignment. Apart from assignment, in examination it may ask some of the question based on the portion which we have covered on the propped cantilever. So, these are the questions, you may note it down. What do you understand by term prop? Discuss its importance. Describe the procedure for finding out prop reaction of cantilever. I hope you can describe the procedure. Derive an equation for the prop reaction in following conditions, that is cantilever carrying a UDL over the entire span and prop at the free end. Just we have gone through this. It is cantilever, not simply supported. A cantilever beam carrying a UDL over a part of the span. For this